Hey guys, welcome to our first live stream session for intermediate algebra. Today we're going to look at some examples for solving linear equations and setting up word problems, so practicing those problem solving skills that we saw in chapter 2. So let's get right into it. We only have a 30-minute window. For those of you who are watching live right now, if you can just type in your name into the chat field, that way I have an idea of who's with us today. As I get to know you guys more throughout this semester, I'll be able to recognize them a little bit better, but this is just going to be a great way for me to keep a record. We're also going to be using this as an opportunity to troubleshoot the live stream. So we might have some hiccups here or there, but with more feedback that you guys can give us, we can improve the live stream and make it better from week to week. So our first example, we are solving the equation for x, y over 2 minus y over 5 equals 1/4. When we're dealing with an equation with rational terms, we want to clear the fractions first by using the LCD. Our LCD for this is going to be 20. So we're going to multiply all terms of the equation by 20. So to show that step, I'm actually going to write it out. 20 times y over 2 minus 20 times y over 5 equals 20 times 1/4. And this allows me to simplify each term individually. 20 divided by 2 is 10. 20 divided by 5 is 4, and 20 divided by 4 is 5. From here, I can simplify. 10 times y is 10y, minus 4y equals 5. Combining like terms, 6y equals 5, and then finally divide both sides by 6. We get y equals 5 over 6. Now, you always have the opportunity or the option to choose to solve this with the fractions. You'd have to find common denominator still there, but you wouldn't be clearing the fractions. It's up to you, whatever you feel most comfortable with, but as we get into more complex rational equations, the ability to clear the fraction using the LCD is going to help you. Next, we're going to look at an equation dealing with decimals. Again, you can continue to work with the decimals, but we're going to practice clearing them out. To do so, we're going to multiply by a power of 10. So 10, 100, 1,000, so on and so forth, depending on the decimals that you have. Since we have two terms that have decimals to the hundredths place, we want to make sure that we multiply by 100. Multiplying through by 100 is going to take all of those decimals and move the decimal point 2 to the right. So this one's going to move 2 to the right. This one will move 2 to the right. This one's going to move 2 to the right, and that's going to actually add a 0. And then 2 to the right. So we end up with 15x minus 3 equals 20x plus 12. From here, we want to combine like terms on the left and right hand side of the equal sign, starting with our variable terms. So we have 15x that we'll subtract from both sides. I'm going to kind of scoot over a little bit. So we have negative 3 equals 5x plus 12. Subtract 12 from both sides. Negative 15 equals 5x. Divide both sides by 5. We get x equals negative 3. So that's just a quick review on some of those maybe less familiar techniques for solving linear equations. Now let's get into some problem solving. The zip codes of 3 Nevada locations, Fallon, Fernley, and Gardnerville ranchos, are 3 consecutive integers. If twice the first integer added to the third is 268,222, find each zip code. So the first step in problem solving is to read the problem and possibly reread the problem so that you understand the information that's given and you also know what you're trying to find. We understand that they're giving us information about the zip codes. We know that the zip codes are 3 consecutive even integers. What's an example of 3 consecutive even integers? Maybe I'm going to write it up here, 2, 4, 6. I know that's nice and small, but I don't want it to get confused with the answer. I just want an idea of what types of numbers they're referring to. I also know something special, that twice the first integer added to the third is 268,222. So we've got 3 zip codes. We've got the first zip code, the second zip code, and the third zip code. Now we go into the next step of trying to translate this information into an algebraic expression or algebraic equation. If we don't know the first even integer, we're just going to call it x. What's the next even integer going to be represented by? If we look at our concrete example up here, we have 2, 4, 6. If I started with 2, how did I get to 4? I added 2 to it. So in this example, if my first zip code is represented by x, the second zip code is going to be represented by x plus 2. Same thing looking at that concrete example up here. If I'm going from 2 to 6, I had to add 4 to it. Since my first zip code is represented by x, my third is going to be represented by x plus 4. Now we're going to use that other piece of information that was provided, that twice the first integer added to the third is 268,000. So that's going to end up giving us an equation to solve. Twice the first integer is 2 times x, added to the third integer was x plus 4, is 268,222. Now we can use this equation to solve for x. Combining like terms, we have 3x plus 4 equals 268,222. Subtract 4 from both sides. 3x equals 268,218. And then to solve for x, we divide both sides by 3. And we find that x is equal to 89,406. Or 89406 when we think about how we say a zip code. So what does x represent? X represents that first zip code. So we know that our first zip code is 89406. Since they are consecutive even integers, the next one is going to be 89408. And the third is going to be 89410. You could have also found the second and the third by plugging them into their respective expressions. A new fax machine was recently purchased for an office in Hopedale for $464.40, including tax. If the tax rate in Hopedale is 8%, find the price of the fax machine before tax. So go ahead and reread that question to yourself, paying close attention to the information that's given and what they're trying to have you solve for. Here we're trying to find the price of the fax machine before tax. They told us that it sold for $464, including the tax, and we have a tax rate of 8%. Every one of us has experience of buying a good that has tax applied. So let's think about this. I go to the store, I find a product that I want to buy, and I look at the sticker price. I know that that's not the price that I'm going to pay at the cash register. I have to think about and consider the tax that's going to be included to that. So the situation that I'm describing is we've got our original price, or the sticker price. We're going to add tax to that, and that equals the price that I paid, or the amount paid. The question is asking us to find the price of the fax machine before tax. So that's referring to the original price. That's how we identify the variable. What are we trying to find? Now, we're trying to find the tax that we add. So we've got 8% of the original, which is X. And we know that the amount paid was $464.40. So we have one more step before we can solve this equation. How do I find 8% of X? Well, we've done this now in several examples. To find 8% or a percentage of anything, you convert the percent to a decimal and you multiply by the quantity. So 8% of X is the same as 0.08 times X. Now we have an equation that we can solve for X. These two terms are like terms. Remember that in front of this X, there's an invisible 1. So 1x plus 0.08x is 1.08x. Divide both sides by 1.08. We get X equals $430. Now, the nice thing with this type of a problem is that we can go back and check because we have a lot of experience in, if we know the price, how much we're going to pay at the cash register. So let's just demonstrate that real quick. If the price tag says $430 and there's 8% sales tax, that means I'm going to add to that 0.08 times 430. What am I going to end up paying when I get to the cash register? We multiply that out and we end up getting the correct value, $464.40. So that's a really great way for us to check our work just by working forwards instead of backwards like we did to find the unknown. I'm rushing really fast. I'm going really fast, guys. Sorry. I'm going to take just a brief pause here. If you guys are watching the live stream and you're logged into your YouTube account or your Google account, if you can type me a message real quick, just hi, Miss McCarthy, with your name. That way I know who's here watching today. Just trying to get an idea. And if there's any issues you guys are experiencing, please jot them down so you can give me that feedback so I can improve the live streams for the upcoming weeks. Can be computed using the following formula. C equals 4H plus 9F plus 4P, where H is the number of grams of carbohydrates in the serving, F is the number of grams of fat per serving, and P is the number of grams of protein. If a serving of cashews has 14 grams of fat, 7 grams of carbohydrate, and 6 grams of protein, how many calories are in this serving of cashews? So we know the formula that we're going to be using. We're looking for the number of calories, so we're solving for C. If we're solving for C, that means we must have the value for H, F, and P in the problem. So let's go find those values. We have 14 grams of fat. That's going to go in for F. 7 grams of carbohydrates. That's going to be our H. Be really careful because carbohydrates and calories both start with C. You want to be careful that you know what variable represents the different components. And then we have 6 grams of protein, so that'll go in for P. Plugging into our formula, the number of calories is given by 4 times H, which is 7, plus 9 times F, which is 14, plus 4 times P, which is 6. 4 times 7 is 28. 9 times 14 is 126. And 4 times 6 is 24. Combining this, we get 178 calories in that serving of cashews. Okay, so guys, that was the last example I had prepared for you. Again, I wasn't really sure what we'd be able to get through. It looks like that took us about 15 minutes. So for future weeks, I will go ahead and plan more examples just in the event that we have extra time. But hopefully this was a good review for you guys and gave you some more examples on how to set up equations from a word problem and another opportunity to review some of those techniques of solving linear equations. I look forward to getting your feedback. Hey, Daniel Ortiz, I just saw that you got in. I look forward to getting your feedback on the live stream, and hopefully we'll see you guys again next week. Have a great day. Thanks.